introduce yourself and start your presentation. Gopal. Thank you. Hello, myself, I am Dr. Gopal Shinde. I am basically mechanical engineer, studied in IIT Kharagpur. I did PhD in CAD/CAM technology, automation in agriculture, and my experience is 20 years, 28 years. Useful for this University of Agriculture, and one of the further perspectives those which I have learned from my past experience. I'm just going to share it that how the drones are applications, drones and its applications are useful to the current scenario as we expect automation. Looking at the perspective, we have a very much privilege that Honorable Vice Chancellor Sir, who is from the agriculture engineering field, and I have always been guided to make the kinds of innovation, kinds of establishment of such a system which will be sustaining to the new generation. And this is what I placed that present scenario in the ICR system. We are first in the technical front to make all our physical presentations with robots. Next, we have a project of 17.87 crores. This project is aiming to first of all introduce that agricultural robotics as an agriculture robot, robotics as agri-bots, agricultural drones as agri-drones, agricultural automatic guided vehicles as agri-AGV, and we have an interdisciplinary approach to make the participation of the traditional agricultural practitioners who are having a lot of think tanks with their experience to materialize it into the automation. So making up this automation to sustainable kind of achievement. And that way we have made the climate-based digital knowledge support system as a CDKS, seedling processing nursery automation as SSPN, smart portable machinery center as SPM, food processing automation center as FPA, instrumentation cell which will make the introduction to all digital technological equipment that we are going to develop next. So in this scenario, we made our approach and we have made a dedicated infrastructure as a DFS RDA, which has been now we are looking at to make the center of digital classrooms, and all the time we are ready to make an online discussions, interactions for the PG PhD students. Or even right now, graduate students have started working to develop their own drones. So we have more than 26 students yet up till now went to abroad. They stayed there for 1 month. When I was here for as a visiting researcher faculty, I mentored 21 students who are doing their research in drone, and it was a NASA project where the drone was expected to make the all hyperspectral imagery sensors to make the quantification of biomass, which will be useful for a government to predict the biomass by use of as it is not available in the market. So students make their own design, they get the camera fixed up and enjoy it as their own technology. Students should learn that whatever the things that are lacunas in the design, they experience and they get it again correct it to the proper way. Once it is get finalized, then that part component can be copied. That can be a these all photographs are from our center. We have experience and we are doing practices to make the automation such that which will be feasible for the farming system. Next. Yeah, the drone hardware is very, it was in discussion. The drone hardware we are supposed to borrow from China. China has firstly took initiative to create such components which are cheaply bringing this component from the China market. But now our India has also started making their own hardware setups. Next. So I do expect that these are all technical sections where we have seen the contribution. 42.9 is that, or we are just now seeing that a photography image processing that attracts to the society. Next. Yeah, this is UAV and UGV, what differences we have supposed to discuss many times. Next. This is all. Next. Yeah, this is our facility where that we are doing in our horticulture, entomology, vegetable plant science department. Next. Next. Yeah, back to this. This is in our meteorology department. Dr. Next. This is a lab where we have a testing kind of thing, mechatronics lab, then hydraulics pneumatics lab, solar system applications. Solar system is a drone. How can we use it? So those are things that we are doing that. Next. This is the SMC SCADA system where we can learn those automation system for the agriculture purpose. Students can have their own small projects. Next. Yeah, this is click on this is a short
transplantation by the drone, carrying from one point to another, putting the hole or placing properly, manual work is required or everything is done automatically?
No, I'm talking about the I'm talking about the transplantation after.
I think we can have this discussion at lunchtime. Okay. On a road. I kept it on the drone, drafted all the regulations also, Dr. Shinde. Thank you very much. Okay. Now, the efficiencies of drones have to come to your presentation also. Make sure the things work. Okay. Next, Dr. Anand Jambe. Is he here? Oh, good, good. So please introduce yourself. Now, all the time the speakers take, they are taking our time from lunch. Okay. So I expect them a little more efficient because otherwise, rather than blessings, you respected Dr. Tejendra Singh sir, Dr. Indramani sir, my professor, sir, all delegates, and my college mates and students. Today, I'm going to talk to you about my organization under Ministry of Agriculture, what we are doing in the field of precision agriculture technology for popularization in India. So, presently, I'm working as an executive director for National Committee on Precision Agriculture and Horticulture, NCPH, under Ministry of Agriculture, New Delhi. Recently, NCPH received a Scotch Award for a project on impact of micro irrigation, water saving technology. Thank you. So basically, NCPH, it was formed in 1981 with the name of National Committee on use of plastics in agriculture (NCPA) under the Ministry of Petroleum and Petrochemicals. In 1993, it was shifted to Ministry of Agriculture. In 2001, NCPA was reconstituted as National Committee on Plasticulture Applications in Horticulture (NCPH) under Ministry of Agriculture. In 2020, when we had a is your area of operations in entire precision agriculture. So our committee was renamed as National Committee on Precision Agriculture and Horticulture since 2020. So this is our organism. Honorable Agriculture Minister is the chairman of NCPH. Horticulture Commissioner, Minister of Agriculture, he is the member secretary. We have members from various department secretaries like Panchayat Raj, Rural Development, Jal Shakti Ministry. So all those secretaries are member of NCPH with some state nodal officers from progressive farmers, etc. Our key achievements in past some years, if we see, the estimation of cost norms and procedural modalities for plasticulture components for operational guidelines under Government of India studies for micro irrigation for highlighting gap areas during the last 3 plan periods for Government of India. Conduct of international and national seminars on micro irrigation, precision farming, fertigation, solar MI integration, local bamboo greenhouses, and allied areas. We are providing technical support to states through SLEC, joint inspection teams, as well as participation in SLC and SLEC meets for artificial lighting as well. So policy for empanelment of greenhouse fabricators under Government of India schemes. So from 2020, our mandate and objectives of NCPH are also changed. The recent mandates are to develop smart and future farming models such as vertical farming, hydroponics, aeroponics, solar powered integrated micro irrigation systems, automation and sensor components, manufacturers, processes for developing quality standards. To develop site-specific advisories with respect to water saving, fertilizer saving, wastewater management, recycling of plastics, etc. In agriculture sector through dedicated web portal. This is under construction now. To suggest ways and means for promotion of precision agriculture and horticulture in the country and revalidate the cutting-edge technologies with respect to precision farming. And conduct applied research, demonstrations, extensions, and dissemination of user-friendly, weather crop-based, agroclimatically differentiated technologies among the end users in the field of precision farming, wastewater management, and plastic engineering. To conduct impact evaluation studies on precision agriculture with a view to collect and consolidate data on plastic engineering applications, including agrotextiles. Yeah. Okay. We have these 21 precision farming development centers where research, demonstrations, and training and awareness programs for precision agriculture are given. Here is the list. I think Dr. Amrish Kumar, he is heading our PMDC in Samastipur, Bihar. Dr. Sunil Gorantiwar is heading in Rahuri. So mainly all the cutting edge technology. This 21 PMDCs. So all the industry and other manufacturers, if they are interested to have a validation with the scientists, they can get attached with our precision farming development centers, respective states, and they can work with the scientists for the validation. So next, so these are there at that time when we designed this software, and it's working well for all farmers, for dealers, distributors of the manufacturers of micro irrigation. So very easy with this software to go for any water requirement of any type of crop in horticulture at any soil. So pan India, we can work for the water requirements and for water use efficiencies and design of drip irrigation and sprinkler system with the help of these softwares. So different types of assignments, different types of projects we are taking in this precision farming development center. Next. So these are again the continuation. Now the researchable areas here in 23-24 onwards, what we are going to do in our precision farming development center. In next 3 months, we are going to have a digital platform in crop protection, harvesting, post-harvesting, and in future, the marketing aspect will also be taken on that digital platform. Mostly in the month of November, it will be launched with the hands of Honorable Agriculture Minister and Secretary of Agriculture. Second, we will be, all of PFDCs will be having completely automation system for irrigation, fertigation, and climate control for their greenhouses. That work also we are going to take within next 2-3 months. We are going to have the low-cost bamboo polyhouses and low-cost cable post polyhouses, shed net houses at each of our PFDCs, because every time we cannot go, all the farmers cannot go for the high-tech polyhouses, but they can start from the low-cost systems. So all these low-cost systems will be developed at our precision farming development centers, and all the new crops which are coming into India, like dragon fruit, like this. I request Dr. Amrish Kumar to give a appreciation. That's why I selected you. Yeah, very good. Excellent. Okay, now we have the speaker, last speaker before lunch. Dr. Narendra Kumar. Yeah. Yeah. Oh, very good. So, Dr. Narendra Kumar, please introduce yourself. Very good afternoon to Honorable Vice Chancellor, Professor. Can we reduce these formalities? No need to address us here. Okay, please straightforward, go to your business. Okay, yeah. I am Dr. Narendra, representing Rashtriya Agro Equipment. Today, my presentation title is A Sustainable Approach in Design and Development of a Tractor-Mounted Irrigation Sprayer. And this is a state of art tractor feature drive irrigation sprayer is being developed by our equipment is basically used for grapes and many other crops like canopy as well as dense farming crops. So all care has been made while design and developing this state-of-art product that integrates engineering and technology with environmental aspects to make it efficient. Also, minimize the human contact. Next. So these are certain glimpses are taken during the experimental trial in the field. Next. So our main focus is on to using of precise spraying technology. We have seen in recent years farmers are facing certain challenges, and now they are more aware and conscious regarding the use of as well as certain environmental impact. Next. So now coming over to the research motivation, which we get constantly, we have taken initiative and developed many equipment, often using pest and vector control that was not only indigenous but also try to use scientific approach. Air blower, and that is connected with connecting hose, and these hoses are connected with two arms, which is provided with number of nozzles equally spaced on the arm, and the air received from the blower is ultimately
mixed with the liquid which obtained from the can, and this proportionate liquid is ultimately converted into fine droplets, and these droplets are used for spraying the target. So this is the flow diagram of our here, and the electrolyte is duplicated with a control panel, and all effort has been made to provide technology while developing this particular spraying machine. Next, so keeping in view of certain challenges, we have incorporated many features in this particular equipment. 40 to 45 liters per acre. So labor use, ultimately all these things translated into the cost saving for our valued farmers. Next. So certain research significance we have already considered while developing this ultra low volume spraying system. So now come to next. So now coming over to the advantages, the users can avail various advantages by using our ULV spraying machine. So the main advantage of our machine is it develops uniform droplet size in the range of 8 to 50 microns, and with new so users can adjust at any suitable angle as well as position for the maximum efficacy of the spraying. So performance of this particular machine is from given and tested, and certain challenges and considerations are also very important for considering or developing any such equipment. So safety measures as well as monitoring and evaluation of the pest, environmental considerations is also very important to aspect here. So environmental impact assessments are crucial when using ultra low volume to validate the results. So in the form, yeah. So these are some photographs we have taken during the field trial, and the copy paper is there. This is to be used for analyzing and getting the statistical data, and after statistical analysis, yes, next slide. Yes, so this is the droplet based analysis we have conducted in our in-house lab. What the data which obtained from the field trial, all the data has been duly analyzed in our full-fledged lab, having constituted with microscope. So now, next. So I would like types of droplets generally received from the nodule, single particle and agglomerated particle. As far as single particle is concerned, here we see around 81% of the droplets are shown within the ULV range. That is more useful for efficacy, and only few percentage, around 6% here is below the ULV droplet range, and 13% droplets are goes beyond the ULV range. So as far as agglomerated particle is concerned, again the similar result is obtained here. Around 71% droplets are found within the ULV range. This analytical results suggest that this particular equipment is more useful, although we are consistently trying to improve this data and trying to reduce some agglomerated particle as well as single ULV droplets that for minimum breathing. So ultimately, I would like to finally conclude with the future aspects. So this is the need of our to scientific people we have to approach all scientific approach researchers come forward and join hand with us to develop such
Thank you, Dr. Narendra Kumar. I request Dr. Syed Ismail to give you appreciation on behalf of. Yeah. Okay, yeah, you go. Good. Well, we are on time. Look at your time, okay? We have three announcements.
Announcement one, we are going to give certificate of participation to you. So be there tomorrow. Hey. So all of you signed by Honorable Vice Chancellor for the certificate of participation. It's a beautiful certificate of participation you get. It's useful. Number two, all the members who are present here for annual or full member of AAE, you will also get a certificate. So that will be given tomorrow. Others can join, some of them join as a new annual member. After they joined, around 7 have joined today. All of you, thank you. But then those 7 also, those who have not got this tag of member, it's not very everything was done very quick, but I think this you will get it. Contact the new ones, please contact and collect it from us. I tried to give. Okay, that's ready. After you complete, you can go. You just go on one floor. Third floor may be. Yeah, already. So everything is done. Thank you.
Okay, so please turn up here on time. You will start on time. Okay? Yeah. Thank you.
number three we need. How to do this? Anyway, we are the only Asian is there. So, now why is it not coming in?